Good afternoon. I don't usually do this kind of thing, but honestly I've been obsessed with this topic as of late, and I just find it really interesting, and I just wanted to make a video just showing the kind of thing that I've been doing, as well as serve as a little tutorial to help other people do this for other games. So I've been obsessed with Red Earth as of late, so I've been learning Lua, and thanks to help by people like Jesuszilla and Ghost Room, I've been able to create scripts in order to basically fuck around with not only Red Earth but other, fighting games that I quite like. This is going to essentially serve as a starting point to people who want to hack CPS2 or free games. It probably works with CPS1 as well, but to be honest, this is mostly CPS2 free thing. So if it's not one-to-one with CPS1, sorry, I guess. I wanted to do a game I've never ROM hacked before, so it's completely naked, right? So there's none. I'm gonna have a list of all the things you need and why in the description, but with that, let's start with the first thing. So, in order for us to be able to actually dissect shit for more than a literal minute, we're gonna find the timer first. So I'm also going to include this cute little thing, so you can edit and whatnot, but it's really simple. Using MAME version that, if you open this up in Notepad, it's very simple. Start MAME exe SFA2, right? So literally just replace SFA2 with the ROM that you want, boom, debug. Gonna open it up. F5 during the screen will start. Doesn't matter who we pick because we're finding the timer right now. So the first thing I should tell you is main debug commands. Go to cheat debugger. For this example, we don't know where specifically the timer is, so we're just going to say cheat init. Don't capitalize it because you look like a monk. You can do all this additional stuff if you want to, but for the sake of this tutorial, we don't need to worry about that. We're going to let the game play for a little bit. We can see what the value is. It's 99. Okay, now it's 98. So, cheat next decrease, comma, 1. So now what it'll do is it'll basically compare this entire list to that condition. So cheat next decrease equals 1. So did that happen? Any cheats that it did happen to, it'll list those instead. So basically the idea is we're whittling down the cheat list until we find exactly what we want. Already, 30 cheats. Obviously these aren't going to be it, because they're too abstract. They're probably stuff like a smaller timer going down for like milliseconds or something, but we don't need to worry about that. Cheat list SFA2 timer dot XML. So what that'll do is when we play it again, it'll create SFA2 timer XML. Here we go. So it'll automatically basically just spit this out, right? So all the values we had, it'll run the script to basically just fuck with it, really. So it'll apply the value that it had at the time into the address that we're looking for. So odds are the address that we want is this one. Since SFA2 already has a cheat, you can go to SFA2. We just set it to possibility. Right? So we'll go back to main. Go to the cheat we made, so possibility that. Set it to on. Huh. I wonder why that's happening. We know it's probably somewhere in that range. We can actually use the script to find where specifically it is. So what we're going to do is we're going to take the address it says, and this is the fun part. So current search address is what you're mainly going to use. So whatever you put in here, it'll basically look at this range in memory. So if we go back into FBA, stop and then start it again, and we look, you'll see the memory is being loaded in real time. and we can tell we were slightly off. Turns out it was a bit further back. So where specifically it is can also be found using this, because Lua does this strange thing, where if a value is blank, it will sometimes display it as 0. So it's not this specific byte that we want. Got it. Okay. So, the base offset is FF2861. Ah, I fucked up this way. It was a byte off. It was literally a byte off. Unfortunately, this is also part of the process, just sort of banging your head against the wall until it works. Huh. I'm not crazy. It is showing the same value as well. The game's fucking with me. Cheat in it. Now the timer has definitely decreased at least a little bit by now. So we'll say cheat next. And we won't give it a specific value, we'll just say decrease. Cheat next. Decrease again. Okay. The reason I'm doing it like this is because if not the main value, what you can do instead is there's usually an additional byte that's constantly decrementing in order to simulate milliseconds, right? So in that instance, it kept going down, 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 but it still hasn't breached less than 0 to make it 98. So it's still a lower value than it was. So we can go back again, and we can say cheat list sfa2 timer test dot xml. Take these. That was gross. It's the sweet Jesus. We can actually freeze the timer now. So it's possibility 2. The nice thing is if you really wanted to, instead of doing a blunt value, you can just put down a variable. So for instance, if I really wanted to, instead of saying that specifically, I could just go timer address. And automatically it would search the range the timer address is at. Boom! We can look for the main value another time, but for the purposes of what we want to do, it's fine. This is fine. Now that that setup is out of the way, this is the annoying bit. First and foremost, we need to find what the player's unit IDs are. Stuff like position and whether or not they're visible is usually close by the start, right? So it's usually stuff like, oh, the object's active, is it initialized, is it visible, blah blah. Another cheat in it. Since I moved Ryu back a little bit, I can say cheat next decrease, cheat next decrease. I'll increase it by a lot, just to make sure it's absolutely certainly bigger than it was originally. Cheat next increase. We're just gonna basically cram our head against this cheat list player.xml. We're going to go back to our cheat file, and once we find the X position, finding the Y position is a piece of piss, because it's usually like right beside it, and I do mean right beside it. We'll go to possibility 1. Nothing happened. Nothing happened. Nothing. Nada. Well, that's not supposed to happen. In order to better find this, let's try something else. We can basically try to logistics some of these out. It's possible these were it, but considering the duplicate values, we're going to probably assume no. Possibility 10 and 9 are potentially interesting. But there's also interval values, so we can probably assume that's not going to be it. The best chance we got is possibility 14. So what I'm going to do is I'm going to get this. Stop. Start. As we can see, certain values are being changed on the fly, which is already a good sign. But that first value is something funky. I'm not sure what it is. But we can quickly test what it is by blanking it. Oh, what the fuck? What the fuck is this? What? I've never seen this shit in my life. So this is encouraging. That's very encouraging. Oh, there it is. There it is. There you are. So the X is probably FF840F. How we can check is by pressing N in the script. You can change what test type it is. It changes from a byte to a word to a double word. So for this instance, we'll just press J. Yeah, bitch. Let's go. Fairly confident in saying the unit ID is definitely close by. So we have the base offset, so FF840F, and we can jot that down. Let's say local player 1. Or I could just put it down, there we go. X pause equals, if I can fucking type correctly, FF840F. We'll keep it like that for now, but this is already looking good, because generally speaking, X position is quite close to the unit ID. So if we go back, and we look around, it's fairly safe to assume that the unit ID is FF83FD. How can we tell? Because this is the earliest instance behind the X position of a value being 1. So it's usually something like active or visibility or something. So test type equals 1. We can just quickly blank this. Yeah, bitch. This is all going somewhere, I promise. Player 1, X, pause, equals player 1, unit ID, plus, how much would it be? So for those who don't know, hexadecimal is quite a weird counting system. It basically goes, instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it goes 0 to 9, and then A, B, C, D, E, F, right? So for instance, D right now, that's 14 in hex. No, that's not 14, it's 13 in hex, sorry. 13 in hex, so plus 3, that'd be 0, and F, 18. So plus 18 bytes. We have the X position, we have the X and Y, we have all that jazz, right? So you're probably thinking, okay, it's neat and all, but how is this useful? And now we can explore the unit ID at our leisure, and we can find what each specific thing does. So for instance, we're going to try and edit the animation, right, to something. For this, we're going to go back and pick Biride. It doesn't matter what character you pick, this process should be like the exact same for everybody. This is where we get to experiment. So, what we want to do is try to find where the sprite is being loaded. And when we do find that, we can do stuff like edit the anim time and all that jazz, right? So, we'll notice down at D word 11, right here, that this is constantly shifting. We can probably assume this is something like the frame time. Yeah, so if we set that to 0, it's a little bit fucked. Doesn't quite like it when we do that. So that's good to know. We know where the frame time is. The reason that we write it like plus unit ID instead is because when we eventually transition this on to player 2, we could just change the player 1 to a player 2. Boom. Instantly know where everything is. Frame time. Let me just, equals player 1 unit ID plus the byte offset this instance, so 36. We could put a little note just saying byte. Well, we could if I wasn't such a fud. Now, in order to find his sprite, we have to look at Biride specifically and look at every single instance of when his sprite changes. But we also notice D word 9 is inputs. We keep going down. Also made it so you can scroll up a bit faster if you press G or H. I prefer using H because it's just, look at how fast that is. And look at that, we found player 2's ID. Oh wait, oh here we go, there it is. So we look at D word 8, we can tell when Biride moves that the value changes depending on it. So we can probably assume that that is the current frame that's being loaded for player 1. Because if we crouch, we notice 18 B7 F2. And it only changes when we press a button to a different sprite and then returns to that. this is going to be the fun bit, because now that we have all of this necessary data, we can use this for something. We go down here to the GUI stuff. So I have this little section just called Atom State Related. So if I go over here, you don't have to do it specifically like I'm doing it right now, but you can if you want. Anyway, so quickly do this. Containers are basically little things that you can update at any given time to store a value that you want to reference. So for instance, in this, we're going to say local player1 current sprite. We don't need them to be anything right now, we just need them to exist. We'll say memory read dword player1 sprite. So what this will do is it will take the memory address specifically we've stated in player1 sprite and will read a dword's worth of information. So basically what the script is showing us right now is what this does, right? So right now it's seeing 18B7A600, right? And it will load that basically. Frame time. But the difference is we don't need a dword, we just need a byte. We'll set it somewhere like, I don't know, fucking, yeah, we'll do that. We'll set it a bit lower down, so we'll say there and there. Player1 current sprite. The reason we're doing this specifically, you're probably noticing that there's this GUI text and there's the string format stuff. The difference is this will just output whatever it's given to it, but it'll output it as a decimal value. So if it was to read A, it would just spit out 10, which for this we don't want. So if we do string format, it'll output the hex instead. Essentially the idea is we're constantly updating it with the current value that's in this memory, right? And we're spitting it out using GUI text so we can constantly see it to the right. So no matter what we do to the search address or anything, we'll constantly have that as reference. We'll just stop this and run it. Yeah! I fucked up the frame time somewhere. Ah, right, it's 54. This is the actual bit that you've all been waiting for. We can edit animations now. What we're gonna do is we're gonna edit that. We're gonna make this fast as fuck. So I'm holding heavy punch. And on this frame, it started up loading the new data. The reason we want to jot this down specifically is twofold. One, to find where it is in particular. And two, we have a specific value to look for. So we know the value is D. Now this bit is going to get a bit convoluted, but bear with me. You're going to need something called xcopy 2009. So the difference between this and normal xcopy is that this basically takes a file and it outputs it as a decrypted file, which normally doesn't sound like much, but the problem is that for some goddamn reason, whenever you try to load up like fucking, I don't know, cyberbots or something, right? In the regular xcopy, you can't edit files, it's very strange. So if I go to SFA2, and this is the fun part. So if we look over here, the offset in the file name. So using what we know, we could try to find the offset, and then we could try to find Biride's data. So 18EOFE, right? So it's probably going to be 18. So SSZ06. We've defined an input file. What I like to do is make a new folder and just call it decrypted tests. Ooh, this one. Don't panic. Don't panic. It may have a different name like that, but it still loads data in the same way. This is mainly stuff like translations and whatnot, so like, don't worry about it. Anyway, we'll decrypt it, and we'll output the file to decrypted tests, and we'll say, what do we say it's called? we'll copy this, we'll paste it. You don't need to do this specifically, but I like to do this just to be safe. Make a new file, just call it decrypted. Paste it in there. And we'll overwrite this file. So yes, that's fine. Now at this point, you can open up any old basic hex editor. For this example, I'm going to use HXD. So the cool thing is, since this is like an individual sim, the offset is automatically applied. So 1/8, don't need to worry about it, right? I mean, we're going to keep it because we need to know where it is specifically, but we don't need to worry about it. We can just go to the offset EOFE. And now this is where shit gets a bit difficult, because I don't know how animations are stored in particular. So I know the first frame is around D. So odds are one of the values was dropped when it was being drawn. So the actual value was 0E. So we're going to set this to something weird. We're going to say like 2, right? You have to input a 0 first because like for whatever reason it like inserts over the byte. It's very strange. Anyway, so 0, 2. For fun, we're going to go and we're going to look at the next frame as well. So the next frame is 116. You can do this ad nauseum to like to figure out the rest of the time. What we're going to try to do is see where the next byte is. 116, so it starts at here. So it's 2 frames as well. So from looking at this, we can probably ascertain where the next bit of data starts. So we can probably assume it's somewhere like that. So all of a sudden, we're starting to understand how SFA2 animation data works, right? But this alone should be like mental fast. But fun. We're going to quickly set that to 1. And we're going to set that to 1 as well. So now when we... Okay, no, I'm getting ahead of myself. So save as. We'll go back to Xcopy that we just had. We'll flip the script and make sure that your input is the decrypted file and your output is the re-encrypted file. So we put it back to 6. Asks us to replace, that's fine. And now, the moment of truth. I know this has been a long one, but stay with me. We're nearly at the finish line. So if we go back and we find our zip for that specific game that we wanted to edit, we can find that game. Open it up. And add a file to it. So A2. Re-implement that file. And now this is the scary bit, because if this doesn't work, I'm going to look like a right tink. So we reload that. Presto! Check it out. So what it's basically telling us is, hey, we're seeing data, but that's not what we expected to see, which is good. You shouldn't be expecting that. So we quickly play this. Straight! And now we press heavy punch. Yeah! Check it out! And that is the basis of how you edit animations in CPS2 and free games. The process is mostly the same for more or less all of the games, really. I've been able to hack VSAV, New Generation, Cyberbots, and I knew nothing about them, but using this specific way of going about it, I was able to edit the animations. So, hope you found this interesting, and go nuts. Let me see what you make. Have fun.